In this lesson, we're going to examine what happens when we have adding and subtracting between rational expressions. To do that, we have to go back to numbers first. The idea of numbers can be applied to algebraic expressions as long as we understand the numerical idea. If I want to subtract fractions, we need common denominators. A common denominator is something that can make both of the bottoms into. In this case, it can make them both into 12s. The second one's already a 12. If I times this by a 4, I can make a 12. Whatever we do to the bottom with numbers, we have to do to the top when we're dealing with fractions. So because I multiply the bottom by 4, I have to multiply the top by 4. And now I can collect. 4 minus 7 makes negative 3 over 12. So if I can, I like to simplify that in the end, because that's what we want to try and do, right? Make it smaller numbers instead of bigger numbers. And negative 3/12 reduces to negative 1/4. Okay? Whatever you do to the bottom, do to the top. That's idea number 1. Let's look at the second one. Okay, a common denominator between 7 and 4. If I can't think of it right off the bat, a good trick is let's multiply these two things together. That makes 28. How did I get the 28? I times the first one by 4. So I got times the top by 4. Times the second one by 7, so I have to multiply by 7. I can then add my tops. I got 29 over 28. The bottom didn't change, right? I can't reduce that. That's okay. Sometimes you just can't. The two ideas we just did here, where we made a common denominator, either by using our brain or by multiplying two things together, and then creating new fractions is something we're going to do when we do algebra. Okay? So, as I was saying here, idea number 1, make a common denominator. Number 2, change the tops according to how you change the bottoms. When you do your adding and subtracting in the end, the top gets collected, the bottom stays the same. Let's try some. So we're going to add or subtract and state any restrictions. We can add and subtract fractions if we have common denominators. I notice they all have x squared. That's a common denominator. If the bottoms are common, we can collect like the terms on the top. 2 plus 9 minus 7 makes 4. There's a simplified expression. Are there any restrictions? Yes, there are. I can't have a 0 on the bottom. So if x was 0, we'd have a problem. I've simplified. Let's try the next one. Slightly more challenging. Do we have a common denominator? Sure we do. That entire expression is common. So on the top, I can collect my like terms. But here's where you have to be a little careful. The top is really 4x minus 1 minus x plus 3. It doesn't show as brackets, but I need to subtract all of this. So it's often easier to write it as a bracket before you try collecting. Because what does that bracket do? Well, when I expand it, it's going to change my signs. Now I can collect. Now it's easier to simplify. 4x minus x makes 3x. And negative 1, negative 3 makes negative 4. And there's my simplified expression this time. My restriction, x can't be negative 2. And now some of us can probably do it right off the bat, get to that. As long as you remember, you need to subtract both x and 3. Okay, just keep that in mind when you're doing subtracting. I personally write the bracket in there sometimes to help remind myself. Sometimes they don't already have a common denominator. You need to create one. Now that's easy with numbers. What can I turn a 4, a 3, and a 2 into? 12. So I can write these as all fractions over 12. And whatever I do to the bottom, I got to do to the top. Whatever I do to the bottom, I got to do to the top. And 4 times 2x makes 8x. And do to the bottom, do to the top. I get 12x. And I can collect my like terms on top. The bottom doesn't change. So this time I'm going to end up with 90 plus 20x on top. Can I cancel? Can I simplify that? I see adding. If I could turn to multiplying, I can cancel. But unfortunately, there's no common factor on top. Can't cancel. Can't go further. Restrictions. Is there anything that makes the bottom equal 0? Well, the bottom's a 12. Just a number. There's no letter I can put in there. There is no letters on the bottom. So I don't need to worry about restrictions in this case. Let's try the next one. What can I make these all into? What do they have in common? Well, 3 and 5 I can make into 15. But then I need to deal with the letters. What can I make x squared and x both into? Hard to make an x squared smaller. Easy to make an x bigger. So my common denominator here is going to be 15x squared. Right? I always make it into something bigger than it used to be. How do I get that? I got to times this by 5. So I got to times that by 5. This is a tricky one. I got to times this thing by 15x. So I need to times this by 15x. And the last one I got to times it by 3. I got to times it by 3. Now I can collect. I'll get 23 minus 30x, no like terms there, over 15x squared. My restriction, x can't be 0. Again, I couldn't simplify this one because nothing on the top can be factored. And let's try the next one. All right, common denominator. Now this is over 1. What can I make them all into? Well, I see a letter M, I see a letter N. I can make them all into MNs. How would I do that? Well, I'd have to multiply it, right? The first one's great. It's done. Don't need to worry about that one. The second one, I got to multiply by n. So multiply by n. The last one, I have to multiply by m and n. Okay? Collect my like terms on top, of which I notice there aren't any. So really, this time, I'm just going to write out the expression all together into one single fraction. Restrictions, m and n, both on the bottom, can't be 0. Done. So far, so good, I hope. But here comes a tricky one. X minus 2 and x plus 3. What can I make them both into? The idea here is there's not much I can do to them to create them the same thing. So like that first question where we had a 4 and a 7 on the bottom, one of our tricks of making a common denominator, if it's not really obvious right off the bat, is take your expressions and multiply them together. That will create a common denominator. It's going to look like that. Okay? And the second one, also the same thing, look like that. There's your common denominator. So whatever you did to the bottom, you have to do to the top. So on the top of this one, I need another x plus 3. I have to multiply it. On the top of the second one, I multiply that by x minus 2, right? I multiply this direction. To simplify this, I need to get rid of those brackets. So I'm going to expand. I'm going to distribute 4 times x, 4 times 3, 2 times x, 2 times 2, and make it into one big fraction. My common denominator, and on top, 4x plus 12 plus 2x minus 4, which can now be collected. 6x plus 8, all over x minus 2 and x plus 3. Now this time I notice the top can be simplified. I can common factor that. And if it can, I should try. It may not always be helpful, but I should try. Because sometimes it will be helpful and we'll miss it if we don't try. That's as simple as that one gets. Are there restrictions? Sure there are. I can't have a 2 on the bottom or a negative 3. Those would be problems. Okay, so there's our second big idea for today. If you don't see an obvious common denominator, multiply your two bases together. I read it to the bottom, do to the top. And last one. 4 over 2x minus 2 minus x over 5x minus 5. So nothing obvious. So let's multiply those two things together. 2x minus 2, 5x minus 5. On the top, 5x minus 5. On the other one, we're missing the 2x minus 2. We want to get this to a single fraction, so we'll expand the top. So 20x minus 20 minus, now here's where you got to be careful. Think of this as, negative x, if you will, okay? So negative 2x squared when you multiply that one, and this one plus 2x all over 2x minus 2, 5x minus 5. All right, we got one fraction. Let's simplify it. Collect our like terms. Negative 2x squared plus 22x minus 20 all over 2x minus 2 and 5x minus 5. Okay, can I simplify this? Oh, I can. On the top, I notice it has a common denominator, a common factor. I can take a negative 2 out of everything. I'll get that. On the bottom, anybody notice this has a common denominator also? Or common factor, I should say, sorry. And the second one also has one.
Would Mr. Maxnell come to the office, please? Mr. Maxnell to the office.
Sorry, it should be x minus 1 there. Which means I can factor some more. X plus 10 and x plus 1. And on the bottom, oh, this is looking kind of crazy now. I've got 2 times 5 makes 10, and I got an x minus 1 and an x minus 1, which means I could simplify that even more. Because the 2 and the 10 can be simplified, right? They can be divisible by 2. And on top, x plus 10 and x plus 1. Now the 1s and the can't go anywhere because they're different signs, but that. Now, that seemed like a lot of work at the end. So, rather than doing a lot of work at the end, could I have saved myself some time at the beginning? So here's what I want you to think about for next time. When we get a question like this, before we start, can we simplify? If I were to take this expression and factor it before I even started, you might notice that they have something in common. They both have an x minus 1 in them. So my common denominator needs an x minus 1 in them. But the only difference really is that this is a 2 and this is a 5. And I can make those both into 10s. And that might save us a bunch of time down the road. What do I really need to multiply the first thing by? Just 5. So I get 20 here. The second thing by just 2. So I get 2x over here. So I end up with 20 minus 2x over 10 and x minus 1. And if I simplify that, I got my 2, I got 10 minus x over 10 and x minus 1, which simplifies to 10 minus x over 5 and x minus 1. And that's way simpler than what we had previously down here. Okay. Now, there's a mistake in one of these because I have the wrong sign somewhere in here. I got an extra x minus 1. How do we do that? We'll work on that after. Anyways, here's some questions to try. See if you can figure them out. The big idea is you have different denominators, multiply them together first. But if you can, try and factor first to see if they have anything in common. Okay?